Dear students, in this video we are going to study about Kirchhoff's first law and second law. Now we are going to study about Kirchhoff's rules. For simple circuits, Ohm's law will be enough to find out current and voltage. But for more complex circuits, we cannot use Ohm's law, but we can use only Kirchhoff's rules to find current and voltage. There are two generalized rules of Kirchhoff. They are called Kirchhoff's current rule and Kirchhoff's voltage rule. First, let us consider Kirchhoff's first rule, which is also called as current rule or junction rule. It states that the algebraic sum of the currents at any junction of a circuit is zero. And it is a statement of law of conservation of electric charge. The charges that enter a given junction in a circuit must leave that junction, since charge cannot build up or disappear at a junction. By convention, current entering that junction is taken as positive, and the current leaving the junction is taken as negative. So here in this diagram, the current I1 and I2, they are moving towards the junction, whereas the current I3, I4 and I5, they are moving away from the junction. Therefore, I1 and I2 are to be taken as positive, as it is given here, and I3, I4 and I5, they are taken as negative as given in this expression. So at this point A, if you apply Kirchhoff's first law, then I1 plus I2 minus I3 minus I4 minus I5 will be equal to 0. This is the algebraic sum of the currents. So this expression can be written as I1 plus I2 equal to I3 plus I4 plus I5. Next we are going to study about Kirchhoff's second rule, which is also called as voltage rule or loop rule. It states that in a closed circuit, the algebraic sum of the products of the current and resistance of each part of the circuit is equal to the total EMF included in the circuit. And this rule follows from the law of conservation of energy for an isolated system. The energy supplied by the EMF sources is equal to the sum of the energy delivered to all resistors. The product of current and resistance is taken as positive when the direction of the current is followed. Suppose if the direction of current is opposite to the direction of the loop, then the product of the current and voltage across the resistor is negative, and that is shown in this figure 2.24a and b. Here V equal to plus IR, whereas here in this case V is equal to minus IR. The EMF is considered positive and proceeding from the negative to the positive terminal of the cell, and that is shown in 2.24c and d. As here V is equal to plus E, in this case V is equal to minus E. So the Kirchhoff's voltage rule has to be applied only when all currents in the circuit reach a steady state condition, and if the current in various branches are constant.
Kirchhoff's first rule, current rule or junction rule, it states that the algebraic sum of the currents at any junction of a circuit is zero. Kirchhoff's second rule, voltage rule or loop rule, it states that in a closed circuit the algebraic sum of the products of the current and resistance of each part of the circuit is equal to the total EMF included in the circuit.
I think I messed up. My circuit readings don't add up. Stop guessing. Use Kirchhoff's rules. They'll fix it fast. Rule 1. Kirchhoff's current law. Currents entering a node equal currents leaving it. Think of water splitting at a pipe junction. Charge is conserved. Rule 2. Kirchhoff's voltage law. Around any closed loop, the sum of voltage rises equals the sum of drops. In other words, energy gained and lost around a loop balances out. Applications? From analyzing complex PCB networks to solving mesh and nodal equations. In power systems and electronics design, keep Kirchhoff's picture handy. He gives you the cheat codes for circuits.